Assalamu alaikum. Hello everyone. Welcome to my channel. My name is Aljazi Al-Hababi. I am a senior mechanical engineering student. In this video, I'm going to show you how to do the flow simulation in the SolidWorks. So this is the vertical axis wind turbine. So let me take you through the process step by step that can help you to know how to do it. Now we will start CFD analysis of vertical axis wind turbine. Firstly, we will go to the taskbar and click the flow simulation, then tap wizard. Now we create the project name. So I will write my name Aljazi project. Press next. From this option, we will select the unit system. Press SI unit. Then next. In analysis type, we will study external, and we will be sure to click exclude internal space and exclude cavities without flow conditions. From the physical feature table, we will start to study a gravity acceleration in the suitable direction. So we can see here, it is show us the Z components. So we will change it to the Y. Change the view. Then we will press and put 0 and go to the Y coordinates and write negative 9.81 meter per second square. And choose the rotation for the vertical axis Y direction also. So press here in global rotation to choose the rotation axis, which is Y direction. Then press OK. And the other parameters we can see here, the arrows counterclockwise. So in angular velocity that we can calculate according to the number of RPM which study, we will write negative 11 rad per second to change the direction of rotate. So now it is clockwise. We will choose next. From the floats table, we will press the gases and choose air, then add. Of course, the flow type for wind turbine is always turbulent. And we consider the humidity parameters. Press Next and tap Finish. So we can see here, we will look at here, there's a box that is known as computational domain. So we will go to the input data and right click on computational domain. That shows the area of the flow. We have to reduce it for many reasons. One of them is to increase the simulation speed when we will run to calculate the studying flow domain. We can also change it by manually, and using these arrows, change the view to the front elevation, by click and drag these arrows like this from left and right side, from top and from bottom. After that, we will change the current view by tab View Orientation and choose the left view to adapt left and right side. There is one more view that we will need to adapt, so we will go to choose top view. Drag it to the down. From down and from both sides, right, then left. You can see now. It's good. We will back to elevation and press OK. Before we will choose the front elevation, then right click on computational domain, to reduce from up and down. Then click OK. The next step, we will go to the input data and press right-click on goals and choose Insert Service Goals. We will select the parameters by pressing the average static pressure, then scroll down to choose the velocity, which is important parameter here. Click average. For studying the wind turbine, Mach number is very important. That is defined as the ratio of speed of the flow to speed of the sound. So average Mach number, then scroll down again to find the last parameter, which is torque, according to the rotation here, and we will study the max torque in X, Y, and Z. Over the parameters, there is a selection area that we will choose the suitable surface of the turbine. So we will choose the faces. We can check. And we will select the shaft. It's okay. And on the right, and select the shaft. Then press OK. We can see all the parameters that have been selected here under the goals. Now we have to run the simulation. Go to the taskbar and press Run. From Run window, it should be select New Calculation. Then press Run. It takes a time, so wait a while for the calculation to be done. So we can see the results that running the calculation in this table that show us the sum values. Back to the program. And change the view. Then go to the results to expand it. Then right-click on Cut Plots, tap Insert, to see analysis on the surface. So we can select the right plane, then change the parameters, pressure to velocity, which is the imported parameter here. Then press OK. Go to the cut plot 1, right-click on it and press play. We can show the flow analysis. Then back to cut plot 1 to stop it. So the scales, the range of this data show us from the lowest to the highest value. So from these scales, the maximum velocity is 50 meters per second, and we will change it to 30 meters per second and press OK. Also change the minimum velocity to 0, that's suitable velocity of air. Then press OK. So we will back to cut plot 1 and right-click, tap play to see the changes, the effect of changes value. By many sides, then back, change the view and back to the cut plot 1 and stop it. So we will go to the cut plot, right-click, tap Insert to add more another cut plots for any directions, and we will choose the top plane and press OK. So we will go to the cut plot 2 and press play. So we can see both of the flows, the top and right. Change the view, back to the cut plot 2, stop the movement and hide it. Then go to the cut plot 1 and hide it also. Now we will go to Service Plot by clicking right-click and tap Insert. So from the selection area, we will choose the turbine faces by going to the model and press the faces. So change the view. Now select the faces and move the model a little bit. Then press this one, this area, and the shaft. Change the view to the left side. It's okay. And the right side. Okay. Then we can press the space button to show all the views. Then press OK. Change the view to the isometric view. And the last step, we will go to the flow trajectories by clicking right and starting points. Choose the right plane, which is the middle of the turbine, to show the velocity distribution for the airflow. Now we will change the number of lines to 200, and here should be lines, and write the distance between line. So from a constraint, we will select the relative to rotating frame. There is a crop region, which is can change it manually. Then select OK. As we can see here, all the lines is shown here from the different sides. Then by tap space, change the view, and we will go to the computational domain and hide it. Then we will go to the flow trajectory, to edit definition, and add to increase the number of line to 400. Then press OK. we can see here the lines. It will increase from all the sides. Change the view, and from the scale we can press the velocity to let's switch to the Mach number, so we can switch between other parameters to show the effects. Look at here, the lines color for the flow is changed. Then change the view and back to the velocity, which is the importance parameter. As we can see, when we choose different parameters, the values will change also. Now we will go to the export results, right click, tap insert, then remove the click mark from use entire geometry and select parts or faces that we need their results. Okay, we should remove all these lines. X, back to the flow, trajectories, and hide it. Then back to the export results. Remove it again and we should select the faces, change the view, press here, and we will press here and here. That's enough. Then select all the parameters and scroll down, press export, tap OK, and press OK also. Change the view. So finally, if we will need to export the values to the Excel sheet, go to the XY plots and insert and choose there, and from selection area we will go to the turbine and choose their edges. So these it's whose values we want to print it. So we will press some of the turbine edges. Okay. Press here. And, here also. Okay. Here. We will change the view to select more of them. View orientation to the top view and press here and here. Click here. Here. So we will select many of them. Here and here. And change the view to the bottom and press here. Okay. And here. That's enough. Then select all the parameters and export the Excel. So far it will take a moment to export all these results to the Excel sheets. By graphing. And it will show us some of the charts, line charts. This is the last step of our simulation. For a while, the Excel sheet will appear as usual. So there are many separated sheets which has the more values, different parameters and different values, as we can see. Velocity, and back to the program. So press OK and change the view. Don't forget to save your work. So go to the file and press save. Okay. And that brings us to the end. I'd like to thank you for your time and being a part of this educational tutorial. I hope you find it interesting and useful. You can share your thoughts or ask a question in the comment section at the bottom of this tutorial. Bye!